Have you ever wondered if it's possible to travel through time? Could we really hop into a machine, press a button, and find ourselves in a different era? This idea has captivated our imagination for centuries, influencing countless movies, books, and scientific theories. The concept of time travel is a mesmerizing enigma, a labyrinthine puzzle that continues to enthrall and confound us. Intriguing, isn't it? But what does science have to say about time travel? Before we dive into time travel, it's essential to understand the fabric of the universe, space-time. Picture this. You're not just moving through space, but also time. As you sit there, you're traveling forward into the future, second by second. This is the idea of space-time, a four-dimensional framework where three dimensions are space, length, width, and height, and the fourth is time. Einstein proposed this concept in his theory of relativity. He suggested that space and time are not separate entities, but rather a combined continuum. Objects, including you and me, move through this space-time, creating a curvature. This curvature is what we perceive as gravity. Imagine space-time as a stretched rubber sheet. When you place a heavy object on it, say a bowling ball, it causes a dip or curve. Now, if you roll a smaller object like a marble, it will move towards the heavier object, following the curve. That's a simplified way of understanding gravity in the context of space-time. So, with this in mind, where does time travel fit into the picture? Enter Einstein's theory of relativity. It brought an interesting twist to our understanding of time. This theory, you see, proposed that time and space are not separate entities, but intertwined in a four-dimensional continuum known as space-time. In this space-time fabric, massive objects like planets and stars create curves and dips, much like a bowling ball on a trampoline. Now, where does time dilation come into play? Well, Einstein's theory also posits that time is relative, not absolute. It can stretch and squeeze, depending on the speed at which you're moving or the gravity you're experiencing. Imagine you're on a spaceship traveling close to the speed of light. To you, time might seem normal, but for a friend observing from Earth, your clock would appear to be ticking slower. This is time dilation. So what does this mean for time travel? If we can manipulate the speed or gravity, we could theoretically control the flow of time. This gives us our first glimpse into the possibility of time travel. Einstein's theory also tells us that gravity can bend time. This may sound like a concept straight out of a science fiction novel, but it's a fundamental principle of physics. This intriguing interplay comes to life in a phenomenon called gravitational time dilation. Here's how it works. Time moves slower in stronger gravitational fields. Picture a clock at the top of a mountain and another at sea level. The clock at the top, being further away from the Earth's gravitational pull, will tick faster than its sea level counterpart. This difference may be minuscule, almost imperceptible in everyday life, but it's there, confirmed by precise atomic clocks in laboratories worldwide. So what does this mean for our understanding of time? Well, it suggests that if you were to spend a significant amount of time near a massive object, like a black hole, you'd age slower than someone far away from the gravitational field. So, in theory, could we use this to travel through time? A fascinating consequence of time dilation is the twin paradox. You might have heard about it. Picture this. One twin embarks on a journey into space, traveling near the speed of light, while the other twin stays on Earth. The traveling twin returns years later to find that the twin who remained on Earth has aged significantly more. But how can this be? This is where Einstein's theory of relativity steps in. The traveling twin's journey involves high speeds and possibly even gravitational fields, both of which can slow down time according to relativity. So for this twin, time has passed more slowly than for the one who stayed on Earth. This isn't just theoretical musing. GPS satellites have to adjust for this kind of time dilation to keep accurate time. So the twin paradox isn't a paradox at all. It's a real-life demonstration of how time is relative. This paradox brings us a step closer to understanding time travel. What if we could take a shortcut through space-time? This is where wormholes come into play. Wormholes are fascinating theoretical entities that can be visualized as tunnels with two ends, each in separate points in space-time. They are predicated on the idea that the shortest distance between 2 points isn't a straight line, but rather a special path through a higher dimension. Now imagine you're a tiny particle, zipping through the cosmos. If you come across a wormhole, you could enter one end and instantly pop out at the other, irrespective of how far apart these 2 points are in the universe. This could potentially allow for faster-than-light travel, or even, in some interpretations, time travel. Wormholes are solutions to Einstein's field equations of general relativity, but they have yet to be observed in the natural world. their existence remains purely theoretical. But the question remains, are wormholes more than just a theory? While wormholes sound like an excellent ticket to time travel, their existence is still theoretical. This is not to downplay their potential, but it's crucial to understand the challenges that surround them. As shortcuts through the fabric of space-time, wormholes provide a tantalizing solution to the puzzle of time travel. However, their existence hinges on the unproven existence of exotic matter, a type of matter that would defy the laws of physics as we know them, possessing negative energy density and a large negative pressure. Additionally, even if wormholes could exist, keeping them stable and open is another mountain to climb. According to Einstein's general theory of relativity, a wormhole, without some form of exotic stabilization, would collapse so quickly that not even light could pass through. Finally, there's the issue of size. Most scientific theories suggest that natural wormholes would be quantum in scale, meaning they'd be far too small for a human to pass through. So, if wormholes are a long shot, what other theories do we have? Quantum mechanics, the science of the very small, might have some answers. As we dive into the microscopic realm of particles, where rules of classical physics make way for probability and uncertainty, we find a world that's drastically different. In quantum mechanics, particles can be in multiple places at the same time, a phenomenon known as superposition. Now let's consider time. Could particles exist in multiple times simultaneously? Quantum mechanics doesn't rule it out. Some interpretations even suggest particles could move backwards in time, a concept known as retrocausality. Consider the famous double-slit experiment, where light behaves both as a particle and a wave. Some physicists argue that the only way to explain such behavior is if the particle goes back in time to know which path it should take. While these ideas are purely theoretical and far from proven, they open up fascinating possibilities. Could the quantum world hold the key to time travel? In the quantum world, particles can be in two places at once. Could we? Welcome to the curious concept of quantum superposition. This fundamental principle of quantum mechanics suggests that a particle exists in all possible states at once until it's observed or measured. Now, apply this to time travel. Imagine being both in the present and past simultaneously, existing in a superposition of time states, until an observation snaps us back into one reality. Intriguing, isn't it? Now let's consider Schrödinger's cat, both alive and dead until observed, demonstrating superposition in a way we can grapple with. But is this feasible for something as large and complex as a human? Quantum superposition currently holds true at the microscopic level. Scaling it up to our macroscopic world is a monumental challenge. Yet, it ignites fascinating discussions, stretching our understanding of time and reality. Quantum mechanics adds another layer to the enigma of time travel. Time travel isn't without its paradoxes. The grandfather paradox is a classic example. This hypothetical situation postulates a time traveler journeying back into the past and accidentally causing the death of his or her own grandfather, thereby preventing the time traveler's birth. It's a mind-bending concept that challenges the very idea of cause and effect. The paradox raises an essential question. If our time traveler never existed, then who caused the grandfather's premature demise? This paradox presents a contradiction that seems to defy logic and highlights the complexities involved in the concept of time travel. Some theorists have proposed solutions to this paradox, such as the idea of parallel universes or the notion that the past is unchangeable, thereby making the grandfather's premature death impossible. But these solutions open up new questions and debates, further complicating our understanding of time. Paradoxes like these make time travel an even more complex concept. It's not just about moving forward and backward in time, but also grappling with the intricate web of cause and effect that governs our universe. But there are theories like the Novikov self-consistency principle that attempt to resolve these paradoxes. This principle, proposed by physicist Igor Novikov, asserts that any action which would cause a paradox or alter the course of history is impossible. Essentially, it states that if you were to travel back in time, the universe would conspire in such a way to prevent you from changing anything. It's a fascinating concept that helps pacify some of the chaos that time travel could potentially unleash. This principle suggests that the universe will always prevent a paradox from happening. So after all this, the question remains, is time travel a reality or just a fantasy? We've journeyed through Einstein's relativity, gravity's time-altering effects, and the paradoxes born from the concept of time travel. We've ventured into the realms of quantum mechanics, explored the potential of wormholes, and scrutinized the Novikov self-consistency principle. And yet, the secrets of time travel remain largely locked away. While time travel remains a fascinating concept, it's clear that we have a long way to go before we can pack our bags for a trip to the past or future. Our journey through time has been fascinating, hasn't it? We've delved into the fabric of space-time, grappled with Einstein's theory of relativity, and pondered the mind-boggling possibilities of wormholes. We've examined the paradoxes time travel might engender and attempted to reconcile them with quantum mechanics. But remember, this is only the beginning. The universe still holds countless mysteries for us to unravel. As we continue to explore the mysteries of the universe, who knows what secrets we'll unlock next? If you enjoyed this journey through time, don't forget to hit the like button. Share the adventure with friends and subscribe to our channel. We're always delving into the mysteries of the universe. And remember, the journey doesn't end here. There's always more to explore. Thank you for joining us on this cosmic adventure. If you're intrigued, delve deeper into the mysteries of the universe with our other videos. Don't forget to hit the subscribe button. Until next time, keep questioning, keep exploring, and stay curious. Before we conclude this journey, let's dare to venture into the future. What does the future hold for time travel? With the rapid advancements in technology, our understanding of time and space is constantly expanding. Could we one day harness the power of wormholes, or find a way to practically apply quantum superposition? Or perhaps we'll discover entirely new concepts that challenge our current understanding. The potential implications are mind-boggling. Imagine being able to witness history firsthand or explore the distant future. But with these possibilities come profound ethical questions. Would we change the past if we could? Should we? What would be the repercussions of such actions? Time travel has long been a staple of science fiction, but as we've explored today, the science behind it is very real. The future of time travel is uncertain and full of mystery, but one thing is sure: it's a thrilling journey, and we're just at the beginning. Stay tuned as we continue to uncover the enigmatic secrets of the universe. As we ponder the future of time travel, it's worth looking at how it's been portrayed in our popular culture. Movies, books, and TV shows have long played with the concept, providing both cautionary tales and inspiring visions. From H.G. Wells' The Time Machine to Back to the Future, Doctor Who to Interstellar, each narrative brings its own unique perspective to the table. Some explore the potential for paradoxes and the dangers of changing the past. Others showcase the wonder and potential of journeying through time. These stories not only entertain us but also challenge us to think deeply about the implications of time travel. They highlight the ethical dilemmas, the potential for discovery, and the sheer excitement of the unknown. They've also inspired many a scientist and sparked countless discussions about the possibilities. While we may not yet have a DeLorean to take us back to the future, these cultural depictions of time travel continue to fuel our curiosity and drive our explorations into the mysteries of the universe. Moving beyond pop culture, let's delve into the philosophical implications of time travel. It's a concept that has intrigued and perplexed philosophers for centuries. The idea of time travel raises many ethical and metaphysical questions. What if you could go back in time and change something? Would it be moral to do so? And if you did, would it create an alternate timeline, or would it change the present as we know it? This leads us to another philosophical conundrum known as the butterfly effect. The theory suggests that even the smallest action in the past could have colossal effects on the future. It paints a picture of a fragile universe where every action has profound consequences. Furthermore, the concept of time travel challenges our understanding of free will and determinism. If the future is already set and can be visited, does that mean our choices don't really matter? Or do we shape the future through our actions in the present? In the realm of time travel, philosophy and science intertwine, each informing and challenging the other. It's a fascinating journey into the unknown, filled with mind-bending questions and thought-provoking debates. Whether time travel will ever become a reality is still uncertain, but the discussions it sparks continue to enrich our intellectual and imaginative landscapes. Let's bring this concept closer to home. Imagine for a moment you had the power to traverse through time. What would you do? Perhaps you would go back to relive a cherished memory or correct a past mistake. Maybe you'd travel to the future to see where you end up, or to witness the progress of humanity. The possibilities seem endless, but with those possibilities come consequences. Would knowing your future change the way you live your present? Would changing your past alter who you are today? The personal implications of time travel are just as complex and thought-provoking as the scientific and philosophical ones. It's not just about the ability to move back and forth in time, it's about the profound impact such a power could have on our understanding of life, identity, and personal growth. It's about the values we hold, the decisions we make, and the lives we lead. Time travel isn't just a scientific concept or philosophical debate. It's a mirror reflecting our hopes, regrets, dreams, and fears. It's a testament to our human capacity to imagine, to aspire, and to constantly seek understanding. Whether or not we ever master time travel, the very idea challenges us to consider who we are, who we could be, and the infinite paths our lives can take. As we ponder the concept of time travel, we inevitably come across a question that has confounded philosophers, scientists, and thinkers alike. What is the end of time? If we have the power to traverse through time, does it have an end? If time is a dimension like space, does it have boundaries? Or is it infinite, stretching out beyond our understanding and comprehension? If it does have an end, what does that mean for time travel? Could we travel to a point where time simply stops? Or would we be trapped in a loop, forever cycling through the same moments? And what about the end of the universe? Would time continue even after all matter has ceased to exist? Or would it too fade away into nothingness? These questions are not just theoretical. They have profound implications for our understanding of reality, existence, and our place in the cosmos. They push the boundaries of our knowledge and challenge us to think beyond our current understanding. It's a journey into the unknown, a quest for answers that may forever remain elusive. But in that journey, in that quest, we find the essence of discovery, the spirit of exploration, and the relentless pursuit of knowledge that defines us as a species. Even as we ponder the end of time, we continue to move forward, propelled by curiosity, driven by a desire to understand, to learn, to grow. The end of time, if it exists, may be beyond our reach. But the journey towards it, that's where the real adventure lies.